To figure out number 1, we want to see what log base 4 is 64 equals, which means we could think about rewriting it as 4 to what power equals 64. So we could think of that off the top of our head and do 4 caret something until we get the answer, which turns out is 3. 4 to the third power is 64. Or if you want the calculator shortcut, you type math, alpha math on your calculator, and you'll be able to fill in the 4 and the 64, and it will tell you the answer is 3. If you don't have the calculator shortcut, then you would need to type log of 64, and it will start a parenthesis, so you will need to close it, and then divide it by log of 4. So without the shortcut, you just do the log of the big number divided by the log of the base, and it will give you 3 no matter what for the answer. So the same thing will apply to number 2. You're trying to figure out 27 to what power equals 243. 27 to the x equals 243. So you can press math, alpha, math. It will tell you the answer is 1.7. Or if you don't have the shortcut on your calculator, you would do log of 243, close the parenthesis, and divide it by log of 27. And then just round it, 1.7. When we read number 3, we have the amount of money in a bank account and the equation that goes with it. So they give us A equals, but we can kind of think of that as Y equals. And they say it's raised to the 12t power. But when we think about it, we'll think about it that the t is an x. So we want to figure out how many years, and time is years, so we're trying to figure out x. It will take for the amount in the account to be more than $800, and the amount is the y value. So basically, when y equals 800, what is x? Well, we could plug 800 in for the amount and solve for x up here, or t, but we'd have to use a whole bunch of log properties. So a more direct way to solve this would be to go to y equals on the calculator, type the equation in, making sure to use an x for the t, and then press second graph, and you'll be able to scroll through all the x and all the y values, and all you're looking for is when y is 800. So scroll down to where y is 800, and the number next to it, approximately, will be your answer, and in this case, it's going to be 24. So after 24 years, there will be more than $800. For a problem like number 4, we just have to rewrite it in log form. So the logs go from the base, 5 to the third power equals 125. Is that what we have? 5 to the third power equals 125? Yep. So how come it's not B? Well, because this one is 3 to the 5th power. We don't have 3 to the 5th equaling 125, so it's not that one, and the other ones don't work either. We don't have 125 to the third power equaling 5, so the other ones are bad. What about number 5? Now we need to go from exponential form, or to exponential form from log form. So we will write 9 to the negative 1 equals 1 over 9. So that matches up with answer D. On number 6, we need to solve for that x that's up in the exponent. So we can use some log properties, but this problem would be pretty easy if we had both sides of the equal sign with the same base. See how that's a base 2? If this side had a base 2 with an exponent, then we would be able to set the exponents equal to each other. So that's what we're going to try to do. We're going to try rewriting 4096 using 2 as a base. Sometimes this works out, sometimes it doesn't. So obviously 2 squared is not going to be it. 2 squared is 4, 2 to the third is 8. So keep doing 2 caret something on your calculator until you come out with 4096. It turns out 2 to the 12th power is 4096. So we will replace the 4096 with 2 to the 12th. So it'll be 2 to the 2x equals 2 to the 12th. And now that we have the same bases, now we can just solve the equation from the exponents. So we'll divide both sides by 2 to get x by itself, and x will equal 6. So this answer is D. On number 7, we need to use a log property, which says that if you have a power on a log, you bring it out front and multiply it by whatever the log equals. So we'll move the 5 out front and multiply it by log base 3 of 9. So now we need to figure out what log base 3 of 9 is, and we'll multiply our answer by 5. So basically, we're thinking 3 to what power equals 9? 3 to what power equals 9? Well, you might be able to think of this off the top of your head. It's 3 squared. So the answer is 5 times 2, which is 10. If you really want to use your calculator on this, you may. You can use the Alpha Math shortcut, but when you type it in on your calculator, your screen will look like this. You'll fill in the box with the 3, and then it will have a parenthesis for the 9 to go inside. You would need to raise 9 to the 5th power inside parentheses. If you don't put the 5 inside the parentheses, it'll say the answer is 32, which is wrong. So if you're going to use the calculator, make sure the exponent goes inside. You will be given the formulas for direct and inverse variation on the exam. So since this one has inverse variation, you should be thinking of the inverse equation, y equals k over x. So since they give us y is 12, we'll plug that in for y. And since they give us x is negative 2, we'll plug it in for x. So we'll have 12 equals k over negative 2. We want to solve it for k, so we know what the equation is. Whatever we get for k, that's what we'll put right in that spot that I circled in green. So how do we solve the equation for k? We multiply both sides by negative 2, and we get k equals negative 24, which means we need an equation that is y equals negative 24 over x. Which of these has negative 24 over x? Answer C. For number 9, we can use the direct variation equation, which is y equals kx. And we have distance is varying directly as time. That means time is the x variable, and distance is the y variable, because distance depends on how long you have been traveling. So we will figure out how long it's going to take sound to travel this far. So the 18,425 is our distance. The speed of sound is a constant, so that's k. So we will plug in the 18,425 for y. We will plug in the 335 for k, and we'll solve it for x, which means we just divide both sides by 335. And when you do that, you get x equals 55 seconds. That means it will take 55 seconds for the sound to travel that far. If you don't want to use the distance or the direct variation equation, you can always use d equals rt and plug in the distance, plug in the rate, because that's how fast it's going, and then solve for time. For a problem like number 10, we're going to multiply straight across the top, straight across the bottom. That's one way to do it, but first maybe we'll see if we can cancel anything out right off the bat on top and bottom that can be reduced. So for example, the 8 and the 4 can both be divided by 4. 4 divided by 4 is 1, 8 divided by 4 is 2. The 9 and the 3 can also be divided by 3. 9 divided by 3 is 3, 3 divided by 3 is 1. So we just made all the numbers smaller. I usually only like reducing the big numbers first, and then I like to use all the exponent properties when I combine the top and bottom. So I'm going to multiply straight across the top now and do 2 times 3. That's 6. Now I'm going to combine the exponents on the x's. So I have x to the fourth and x to the first. And remember, when you multiply with exponents, you add them together. So when you see multiply, add the exponents. So x to the fourth times x to the first is x to the fifth. Y to the second times y to the second is y to the fourth. And then we have z to the sixth. So I'm just multiplying everything across the top. Now I'm going to multiply everything on the bottom. 1 times 1 is 1. And now I'm going to put the y to the fourth right underneath the other y to the fourth. And I'm going to put the z to the third underneath the z to the sixth. That way everything is stacked on top of each other for like bases. Now I'll reduce. Since I have y to the fourth and y to the fourth on top, they cancel out. And the rule for dividing with exponents is that you subtract the exponents. Always top minus bottom. So I will do 6 minus 3 for z to the sixth divided by z to the third. And my final answer will be 6 x to the fifth, the y's were gone, and then z to the third. So that answer is right there. It's letter C. For number 11, we want to solve for x. We have x's on both sides. This x is underneath the fraction bar, and that is probably the worst thing about this equation. The x is underneath the fraction. Well, let's get rid of it by multiplying. That'll cancel it out. If we multiply this side by x, we need to multiply everything on the other side by x, which means we'll need to distribute that x to both terms. So it'll be x to the second, x times x is x squared, plus 5x, because x times 5, and it equals negative 4. Notice that negative sign in front of it. So we have a quadratic here. Since it's x squared, it'd be great if we could factor it. In order to factor it, it needs to be set equal to 0. So we need to move this plus 4 to the other side. We'll do that by adding 4. And now the whole thing will equal 0. We have x squared plus 5x plus 4 equals 0. So we're going to get the two factors that multiplied together to get that. So it's x times x. Factors of 4 that add up to positive 5 are plus 4 and plus 1. Since those are the factors that equal 0, we take each of them and set them equal to 0. X plus 4 equals 0 and solve it. So that means, you remember you just flip the sign basically. So that means x equals negative 4. And then we'll take the x plus 1 and set it equal to 0, which means we'll subtract 1. So essentially when you switch this sign, it's x equals negative 1, and that is answer C. Number 12 is so amazing because both of these fractions have the same denominator. And when the denominators are the same, we can just cross them out. If they weren't the same, we would be cross multiplying right now. But they are the same, so we just need to solve the top. 5x equals 3x plus 16. So first step, I'll move the 3x's over to the other side, which means 2x equals 16. Divide both sides by 2, and we get x equals 8. The only thing we need to check, because we did have an x on the bottom, is our excluded value. What's the only number on the bottom that would make that denominator 0? Well, if you set it equal to 0 and solve, the only number that would make it 0 is positive 4. So that's our excluded value, because if x is 4, 4 minus 4 would be 0. Did we get 4 for the answer? No. X is allowed to be 8, so our final answer is 8. If we happen to solve this and got that the answer was 4, and 4 was the excluded value, then we would say we have no solution. For number 13, we need to first simplify this expression by seeing if anything will cancel out on top with that x plus 6 on the bottom. Maybe it will, which means we need to factor the top. We're going to factor this. So, what are the factors of 18 to subtract to get 3? Positive 6 minus 3 is positive 3. So the top factors to that, we have the x plus 6 on the bottom, and those are the factors that cancel out. Because we had the same factor on top and bottom, that tells us that there will be a hole in the function, which you sort of already knew from the instructions. So we have to graph the function that's left, which is x minus 3, and we'll put a hole through the graph where the denominator is undefined. So what value of x would make the bottom equal 0? Well, if you set it equal to 0 and solve, we'll see that the hole will be at -6. So what we are going to do is graph this equation and put a hole when x equals -6. So we'll start down 3 because that's our y-intercept. Our slope is 1 over 1. So we'll go up 1 over 1. The scale is kind of hard, but the line will look like that. The hole at -6 means when x is -6, so right here, it means that line will have a hole in it. So basically we just need to match up our answer with the correct multiple choice, which is only answer A that has -6 being the hole. So this answer is A. When you see a problem where you're trying to figure out how many different possibilities, how many different groups are possible from a certain number, you should think permutation and combination. And then you should think, does the order of the items being selected matter? If you're creating a committee and all the members are equal, order that they are chosen does not matter. So that means, doesn't matter. That means we have a combination. So we can use the combination formula, NCR, that is a shortcut found on your calculator, which means first we need to type in the number for n, which is always the biggest number. So on your calculator, you'll type 25. Then to get the NCR to show up on your screen, you're going to type math, hit over to the probability menu, and then pick option 3 in this case. 3 is NCR. And then it'll show up on your screen. You will type 4 for R, hit enter, and you will see the answer is 12,650. And number 15, we want to count the number of ways we can select a principal and assistant principal from a group of 6. So we think to ourselves, is this a permutation or combination? Because we're trying to figure out all the different possibilities for these people to be chosen. And in this case, it does matter who is principal and assistant principal. So for that reason, this is a permutation because it matters who does what. So letter C. For number 16, we want the probability that a person was not born in the month of June. That means they were born in one of the other 11 months. That's known as the complement. So since 11 months are not June, out of the 12 months we have, you just divide 11 by 12, and you get the decimal 0.916. So we multiply that by 100, and our answer as a percent is 91.6%. What about number 17? We have a bag with a bunch of different colored crayons in it. We want to select a blue one. Well, how many total crayons are in the bag? What's 5 plus 3 plus 7? That totals up to 15 crayons total. And we want a blue one, and there are 5 blue. So can we reduce 5 over 15? Yep, it reduces to 1/3. We talked about a couple different examples of independent and dependent events. Independent events would be like a coin flip. When you flip a coin one time, that in no way affects what's going to happen on the second flip at all. So we want a definition where the probability from one event doesn't affect the probability of the other event, and that would be option B. The definition of A, in case you're confused about this, would be mutually exclusive. Letter C is the definition of a compound event, and don't worry about answer D. All right, number 19. We have a normal curve. You should recognize that bell curve shape is a normal distribution. So we want the percent of washing machines, that's what we're looking at the normal curve for. We want the percent that's going to last between 9 and 13 years. So between 9 and 13 years, we need the percentage that falls between those two numbers. Well, a normal curve is always divided into the same percentages. 34% of the data falls above and below 1 standard deviation of the mean. The next section is 13.5 and 13.5. We don't need those remaining two sections. If you did want them, they're 2 and 0.5 on each side. So all we have to do is add up 13.5, 34, 34, and 13.5, and we come out with about 95%. For number 20, all we need to do is figure out which one of these, mean, median, mode, or range, is the most popular. So the most popular flavor of ice cream will be the one that people buy the most. And the measure of the most is the mode. Some people remember because mode kind of looks like the word most. So it'd be answer C. For number 21, we just need to match the shape of the graph with what's happening. So I just like to draw arrows by the words. A restaurant steadily got busy until lunch. That means the number of customers they had was increasing. Then at lunchtime, people just stayed there. Nobody left, nobody came, so then they left. So we're looking for a graph that goes up, stays the same, and then goes down. That would be graph D. For problem number 22, this is a conic section problem. You will be given the formula sheet for all the conic sections. So you'll have the circle formula. If you look on your formula sheet, if you have it handy, it's x minus h squared plus y minus k squared equals the radius squared. So that means we take the 5, because the center is hk, and we put it where the h goes. We take the 1, we put it where the k goes, and since they're positive, it means the signs in front of them will stay negative. And then we just have to square the radius. So we just have to square the 7. 7 squared is 49. So all of these have x, well, not all of them. We're looking for an x minus 5, so it could be this one, or this one, and a y minus 1. And then we need the radius to be squared. This is a problem because these don't have the squareds around the parentheses. That one's the wrong order for the center, and C does have 49 squared, so the answer here is C. Number 23 is the opposite. To get the center, we take the opposite of this sign, so negative 3. We take the opposite of that sign, so positive 4. And then we have to square root the radius. So the square root of 36 is 6. So that will be answer B.